And let's hit record, yeah.
Yep.
And Benoit, if you can let people in while I'm chatting.
I can do that. But are we being recorded? Let me see.
Oh, and I got to put the
Yeah, we are. We're good to go. All right.
Okay. So everyone, before I get started, I just put the link to the question and answer doc into the chat. You should click to that because the way we work is you put your questions in there, and it's a like a stack. So we start with the first question and we go to the last. So we'll use that doc for purposes of getting your questions in so we can answer them after the presentation part when we go into the discussion section. Okay. Good morning, everybody. I'm in a public place. I'm going to try to talk quietly. There's not too many people around, so I don't think I'll be in too much trouble. Welcome to our discussion today on Contextual, how increasing input tokens impacts LLM performance. This is a fascinating topic, may I say, because I am a wordy prompt engineer, like all good data scientists, and I write very long prompts. So this was very relevant to me. Our speakers today are Kelly Hong. She's the author of the paper that we're going to review. She's a member of the technical staff at Promo, which I have to clarify is not the embroidery AI company. It is the database AI company. We have Adam Becker, who is the founder of Head On and has been, I think all of you know Adam pretty well. I got to say this right, Brennick Meyer, who is an AI engineer at Work.ai. And of course, our inestimable Matt Squire, who's the CTO of Fuzzy Labs, who publishes all kinds of interesting newsletters on various AI topics. Now, we all love talking to you. So below, you'll see how you can connect with us on LinkedIn. And do me a favor, because I get a lot of fake people coming. When you do, please add a note that says you are from MLOps, so I know that it's you. I get about 10 new people after every one of these sessions. So please let me know it's you, and I'll make sure to connect with you. The agenda today is we'll start with an introduction and related works. Kelly is going to cover that. And then we're going to talk about NQS and impact of distractors. That's going to be Adam. And distractors are an interesting topic. Matt's then going to talk about the haystack in which the needle occurs. Then Valkyr is going to talk about long Memeval and the related words that go with things. And we'll be doing some survey questions in between the speakers, although today I've kept that to a minimum. Guiding principles, for those of you who've been for before, this is old news, but let me just repeat it again. These are your sessions. This is not us to present. This is for you to learn. Sessions are intended to be interactive. We'll present for 35 minutes, and then we have great discussions. We have had the last sessions, fabulous discussions. In fact, in many ways, the discussions gave us more insight than the presentations did. The more you participate as a result, the better the outcome for all of us is going to be. And let me say, because I'm the guy who always asks the dumb question, ask the people on this call when we get in meetings about organizing, whether I ask the dumb question or not, is a no judgment zone, which means any question is fair game. Do not be afraid. While we're here, no one is going to judge anyone else. There are no dumb questions. And as I said earlier, the questions go into the Google Doc and will be answered in the order received. Lastly, we have a post-event survey. We want to do better every time, so please fill out the post-event survey that you'll get an email about. And with that, I will turn it over to Kelly. Let me stop sharing. Kelly, you are up.
Thank you. Also, do we have some sort of like, I guess like shared document to like screen share, or should I share on my screen?
You're talking about like the doc for questions or?
Oh, no, just like the technical report. Like I was wondering if we're gonna share that on the screen, or I can do that on my own too.
I think you should probably do that, Adam. Agreed?
Yeah, either that or I'm gonna share the mirror board later, so I'm happy to do that already now if you wanna drive it around, but it's probably fastest. I mean, if you have it easy accessible, you should do it. Otherwise,
Okay.
yeah.
Yeah, sounds good. Let me just share my screen. I just have like one visual to reference, so let's see. I'm facing some trouble. Wait, I'll just present and then we can do the mirror board later. But yes, so I'm Kelly. I'm a researcher at Chroma. as Arthur mentioned, we're a vector database company. So we work on retrieval for AI, but we also work on a lot of research on the side as well. So Contextual was one of the recent technical reports we published, and it's basically on how increasing input length degrades LLM performance. So I'll kind of start with the motivation for this research. So a lot of labs have been coming out with larger and larger context windows. So you've probably seen like Gemini, GPT 4.1, and most recently Sonnet 4. They all have 1 million token context windows. And this is typically presented in a way that makes it seem like these models maintain performance across their entire context window. So like regardless of if you have, like a task at 1,000 tokens versus 1 million tokens, it's kind of assumed that, they'll have good performance regardless of how long your input is. But there's a few problems with how this is presented, and I'll go into one of the reasons for why. So they commonly use this test called needle in a haystack, which we'll go very deep into, I think, throughout this reading group. But it's essentially a very simple retrieval task where you have a long document. Say you have like polygram essays or like research papers, and they all add up to like a long like token length. So they could be up to like 1 million tokens. And we call that like a haystack. And within that, you have a question needle pair. So you would have some fact like within the middle of that very long document. And then you basically prompt the model to retrieve that fact. And this is essentially like a very simple retrieval task. And it's a good scalable test because it's easy to adjust the length of your inputs. But the problem is that this test is also very, very easy for LLMs because, first of all, it's like a simple retrieval task. You're only telling the model to pay attention to that one fact within the entire document. You don't really get insight into like how it's processing the rest of the content. And the needle question pairs are also like perfect lexical matches a lot of the time too, meaning that they contain a lot of like word overlap, and it might not be like semantically understanding like the needle in question every time. It might just be, just doing like word matching. So this doesn't really compare to how people use long context in practice. Like for example, if I take a coding agent, for example, it can have like hundreds of tokens of like code files, like tools and previous conversation history. And you can prompt the model to do some coding task. And this kind of task is a lot more complicated than, just having like a simple needle in a haystack retrieval task. So it's kind of hard to generalize, like how does this performance on needle in a haystack um, like generalize to more like complicated realistic scenarios. So the conclusion we had was that these current benchmarks aren't very comprehensive, and thus they can be pretty misleading for people to think that they can maintain performance, regardless of context length. And I know this isn't entirely a new context. I'm sure a lot of people have experienced context rot, in practice. I've experienced it myself, in my daily use. But basically, anytime you have like a long conversation, whether, that's just like back and forth with ChatGPT or you're using some kind of like coding agent like Cloud Code, you can kind of start to notice that you get like lower quality inputs as the conversation progresses. Um, so this is something that I think a lot of people have resonated with, but it wasn't something that's been thoroughly tested yet. I think like the most that people have done is like needle and haystack and some other benchmarks too. There's been like MRCR and like GraphWalks as well, but these models haven't been like very thoroughly tested and like quantified for how they perform across, their entire context window. And that's essentially what this research does and what we'll be going into today.
Right. Adam, I think you're up.
Awesome. Okay, so Kelly, thanks for the introduction, and also thanks for being here with us and telling us about your research. It's interesting
thank you for
because
having me.
we were maybe, I guess, also potentially guilty of some of the hype, because I remember it must have been maybe like a few months ago, we were talking about a paper about, maybe it was when Gemini Pro came out or something like that, and everyone was just like railing and excited about the extra context window. And what it actually, like just having a sobering analysis of what the actual impact of this and what is an actual effective length that we can actually use is, I'm not sure that was done back then. And so I think that you were called to task for it. So it's very fun and energizing to see this work being done. So, okay, I'm gonna talk about a few things. Let me share the Miro board. You guys know that I like to draw these things. If people want access to it, also, I'm happy to drop it in the chat. So we go for it here. And okay, if anybody wants to follow along. So the way we're going to do it is we have a bunch of different sections for each of the experiments that they ran. And I'm just going to spend 2 minutes on the needle question similarity. And then we'll open it up for questions, right? For Kelly for a few minutes. And then we'll go on to the next section, which is the impact of distractors, and then come back to questions. I think that's the structure that I'm following. But Arthur, if I'm off,
No,
then
my bad, Adam. You're right. We decided to do it this way this time. I was following the old, so thank you for correcting me. That is correct. So you use the Word doc, and we'll answer the questions in order after each section.
Okay, cool. So the first one is needle question similarity, which I think is a fascinating topic, even not in the context of large context windows. I think that even just the needle question is very interesting. So the classic needle in a haystack, that's the thing Kelly had already gone over. The idea here is just, let's say we have a whole haystack of information that's not quite necessarily very pertinent to the answer. For example, I've discovered a handy test for figuring out what you're addicted to. Imagine you were going to spend the weekend at a friend's house. Okay, it's something distinct, and all of a sudden the needle, the right answer is, the best writing advice I got from my college classmate was to write every week. Okay, so this is the needle, and this is what we're trying to find. The question is, what was the best writing advice I got from my college classmate? So this would just be a typical, classic needle in a haystack setup, right? We see the needle, it's buried in the haystack, we have a question, let's identify it. Let's see if the LLM is able to pick it up. Okay, so now let's figure out, what do we make of the relationship between how similar the needle is to the question? Because maybe it's very easy when they're very similar. It says classmate, it says classmate. It says best writing advice, it says best writing advice. Okay, they're pretty similar, so maybe it's... But maybe if they're very similar, but now you increase the context window, now it's very difficult. Or maybe if you shorten the context window, even if they're very similar, maybe it's easier. So let's actually see what the impact is of the similarity between the needle and the question. So, okay, the goal is to vary the similarity between the needle and the question and see whether it degrades, right? The performance of the LLM degrades with increasing context length. That way we can build intuition about how increasing length adds to the difficulty of it. So they go through a process here of how they actually went about it. I think I went over this a few times, and I realized that maybe the best way to think about it is not to think about it at all for a minute, and just to see, if you were to try to replicate the type, like this experiment, what would you do, right? What actually matters here? How would you run an experiment like this? And once you build up that intuition, I think that flow makes sense. So I think the requirements need to be that the needles should naturally blend in so that they're not odd sentences out, right? So let's say we have the haystack here being, let's say, like Paul Graham's essays. And now all of a sudden you put in a needle that talks about cooking. Okay, it might be very easy to tell it because it's pretty different from everything else. And so it's easy to pick it up. So we shouldn't make it too easy. Let's blend it in so it looks natural. Next is we need to control how close the needle is to the question, right? So maybe instead of cooking, you talk about food. Maybe you talk about nutrition. Maybe you talk about diet. So how close do you want those to be? And then we need to make sure that there aren't any other answers in the haystack already. Arthur, I might be running out of time. Let me know if I am, but I'm getting close to the punchline. So we need to make sure that if, for example, the right answer has something to do with cooking, I want to make sure that there aren't a bunch of other right answers there where the LLM just could guess even at random because there's a bunch of needles or a bunch of hay that looks like needles. So let's make sure there's no needle-looking haze in the haystack. So if those are the requirements, what you want to do is actually look through the haystack, try to pick up the right topics, understand what the topics are there, and then come up with a question and invent a bunch of answers and embed those answers in, and then run the test. So this is what they do. They chunk it. So they take all of, let's say, Paul Graham's essays. They chunk it into 1 to 3 sentences. They take each of these chunks and embed those. Now we have, let's say, this thing is like 3,000 dimensions. Well, you can't really do clustering all that effectively then, so you're going to reduce it down to 50 dimensions. Then you find the clusters. Then you get 20 representative chunks from each of those clusters. And now let's manually review those so you get a sense of, okay, what are they actually talking about and what's the style? And then you find meaningful topics. And let's say the topic is writing advice. So you say, okay, Paul Graham's essays, they tend to talk about writing advice. Fine. So now let's invent the question. The question we invented was, what was the best writing advice I got from my college classmate? Let's invent an answer. So we can invent one answer and make sure that answer isn't actually already in the haystack. So that we could do that, or we could do it a bunch of times. Let's come up with 8 different answers. So 8 different needles. Each of those is a little bit further away from that question. How do we know it's further away? The cosine similarity is a little bit lower. So now we take each of those and we're going to bury them into the haystack. And we need to see whether the LLM is able to pick it up, even if we have a very large haystack. So that's basically the experiment. What is the results? Well, first they have, I think, 18 different models that they're going to try this out on. And now they're mapping the results. So this at the top here, you see this is for the models that take over 500K tokens. And you can see that as the blue one at the top is the high similarity. That's when the question and the needle are quite similar. The red one is when they're less similar. You could see that as you increase the input length, from 1,000, 10,000, by the time you get to 100,000 tokens, even the highly similar needle and question, they start to degrade. Now, it certainly starts to degrade if they're not even all that similar. If they're not all that similar, it's a very fast drop. Even worse for medium performant models, right? So this here, you just see the high performing ones. You can get a sense here, I imagine, which ones are the high performing ones. The ones that are medium performing, you can see that even for the medium performing, even if they're highly similar, it's going to start to drop. Certainly is. So I don't think there's anything that's too surprising here. But if low performing models, you just keep giving it lowly similar, quite dissimilar question needle. It starts out bad and it gets much worse.
Okay, let's stop there.
It's
Questions.
nice.
Let's go to the question board. And I'm on my own machine here. I have to pop between the view of you guys and the question sheet. So pardon me if I'm not looking at you right now. So the first question was from Tudor. Tudor, you want to ask your question? Tudor, you there?
I think he might be at work. So could you just read it
Okay.
out, Arthur?
Okay. Do you have plans to expand the current research? I guess that's for Kelly.
Yes. I think he just sent a chat in the meeting chat as well. But I can answer it right now too. As of right now, no, we're not gonna do like a technical report that directly builds on top of this. But yeah, so nothing like from Chroma directly, but we have been seeing a lot of people, I think like you mentioned here too, like you made like an interactive version, which is really cool. I'd love to take a look at that if you like share a link. But yeah, there have been people like kind of building onto this research, which has been really cool to see. But yeah, I think like for Chroma ourselves, like we won't be doing something that like directly builds on top of this.
Okay. I don't have names next to this next question. So do we know whoever asked it? Could you jump in and ask your question? How many real world applications? No? All right, I'll ask it.
Yeah, that's mine. Yeah,
Okay.
I was wondering, like, I'm seeing like a lot of applications that are not in the form of an haystack.
Yeah.
For instance, like summarization or like analyzing a piece of data or code generation, right? Where you need, where the LLM needs to analyze the complete context that you provide to it. So how many like real world applications, I guess, apart from like RAG, are in the form of needle and haystack?
Yeah, that's a really good question. I'm glad you asked that. That was something I was thinking about a lot too as I was designing these experiments. And I think for needle in the haystack specifically, like it's not a very realistic task. It's a very like controlled task, and we explicitly chose this because it's one that, it's easy to like control variables for. Like for example, you can just like increase input length by like appending more essays. We can, control like the position of like the needle in question, and we can also control for like things like similarity as well. So I think the main point here is that like we were able to see non-uniform performance on this very easy task. Like needle A haystack is very easy relative to the tasks you mentioned, like agent tasks or tasks like summarization, where you have to tend to the entire context. Like for this same model, really only had to tend to like that one like sentence within the entire context, and it still start to fail across like longer context lengths. So I think we can imagine that this kind of performance would translate over to more complicated use cases as well. Maybe you'd have even like worse performance because the task is even more complex. But for those tasks, it was more difficult to do experimentation on, because if you have tasks that require attending to the entire context window, then you also have increasing difficulty as you increase like context length. Like for example, if you have like, some like agent task and you give it like code files, like a bunch of like tools, and you have a task that requires the model to tend to like 1,000 tokens versus like 100K tokens. The 100K token version is a lot more complicated for the model, so it's kind of hard to like disambiguate whether, like model failures are due to like just task difficulty or if it's just like context length. So I think we wanted to like separate out those two variables, which is why we didn't like design experiments that are like directly applicable to like real use cases. But I think we're kind of like doing the simple experiment showing that models fail on these very simple tasks. Therefore, like you can imagine that they would also fail on like more complicated tasks. I hope that makes sense, and kind of like our motivation for how we design these experiments.
Yeah, that makes sense. Thank you so much for the answer.
Yeah, thank you for asking.
Are there any other questions? There are none in the queue.
I just added the question to the
Oh.
queue.
Ah,
Okay, let me see.
So so my question was that looking at the results,
Mhm.
it seems to be so Adam mentioned initially that if the questions are not blending enough with the text, we expect them to stand out, which
Right.
I relate to perhaps a higher chance of retrieval, so a better
Mhm.
better retrieval chance. But in these results, we see the exact opposite, right? Where things that are not similar are
Mhm.
harder to retrieve. So do you have any feeling of why that is the case? Because it seems a bit counterintuitive, perhaps.
Could you clarify the counterintuitive part? Yeah.
So I think Adam kind of described the intuition in the beginning that if things are dissimilar from so the needle is dissimilar from the background that it's blending in with, it would
Right.
stand out, which could perhaps lead to an easier easier retrieval for the model. Easy is maybe the wrong word here, but it stands out from the
Right.
environment.
Yeah. Yeah, so for the needle haystack similarity needle question similarity experiments, we did that across all like needle and like haystack pairs. So it could be like a needle that's related to like the writing advice, and it would be like within a polygram essay haystack. We also did that same needle on writing advice across like the archive haystack as well. And we did like a research question on archive haystack, research question on like polygram essay haystack. So for needle question similarly, we did it across like all those combinations. And the only thing we were like manipulating was like the needle question similarity. And we kind of define that as like a highly similar needle has very high like lexical matching. So like a needle and question pair have like word for word matches, whereas like lower similarity needles, they have more like semantic similarity. So you could have like a question like, oh, like what was like the best writing advice? Like a low similarity needle would be like, oh, like one time in my English class, like my classmate told me like blah blah. So it's like a lot more, I guess, like harder to like match like a needle and a question. So yes, we go more into like needle haystack similarity like later on. But like for this one specifically, we are only changing like the similarity of the needle and question.
Okay, yeah.
all right, we
Clear,
have to
thanks.
move on to Bowker since you're up. But I will say I'm at the end, I want to talk about ambiguity on this subject. What caught me about it, Kelly, was that we never defined it in the paper. And I will talk to you a little bit about what I discovered and either supports or not. your
Okay.
approach. All right, so
Sounds
let's
good.
go on. Bowker, you're up.
All right, let me see if I can make this thing full screen.
Good questions, everybody, by the way. And also during questions, I would love it if people put their video on so we can actually see everybody, like it's a real human discussion.
Yeah, but I think a lot of people are actually at work and they're listening to us in the background. So thanks for that. Yeah, all right.
Well,
So
whoever can, whoever can. I understand the issue. It'd just be, I saw the tutor was at work, but I saw him, he was on for a while, for
all right.
example.
So before Bowker starts, let me just give a quick introduction. Bowker is the chapter lead of our Amsterdam chapter, and he scaled up Amsterdam in-person community quite a lot, and he's an absolute legend for doing this. So yeah, over to you, Bowker. Thanks for being here. There you go.
As he's pulling it up, I will also give a shout out. I went to hang out with them in the Amsterdam meetups a couple of months ago, and it was a sick scene. So, Bauka, well done.
He's back. He's back.
Back. All right.
He hit the wrong button probably as he was trying to start the share.
Not the wrong button. No, I realized Zoom didn't have the permissions to share my screen. So now we're all good. So I quickly rejoined as I was being introduced.
Yeah, you missed all the good words people said about you.
I heard all the niceties at the beginning at least. Let's see. This should be the right one. All right. Okay, I hope you can see it now. Yeah.
Yep.
Okay.
Yep.
Good. So where did I put my things? Yeah. So I'm going to be talking about the Memeval experiment, which I thought was one of the, I don't want to pick favorites, but I think this was one of the more interesting ones, at least to me, relating it to real life usage, perhaps for myself. So the long Memeval is a benchmark. And essentially what we're going to do here is evaluate complex Q&A for long context with chat data. So the data here is, I think, also actually coming from like a ChatGPT type system. And the benchmark has these different types of questions, for example, knowledge updates, temporal reasoning, and multi-session that it does over these long contexts conversations. And so long context, I think it ranged from about 50,000 tokens to 100,000 tokens, but so really significant chunks of text. In terms of the experiment, so the retrieval tests were done both on the full input and then also on the focused input, which only contains the chunks that are relevant for the specific question being asked, just to compare, okay, how much is the impact of the additional distractors or the additional context that we're working with. So quite a simple, neat experiment. And I think we can just jump into the results immediately. So I did shuffle the results around a little bit because this one, I think looking at ChatGPT is a good start. And here we see quite interesting. So the focused chats are in orange here or red, and the blue describes the full context retrieval, and then we have all the different models on the x-axis and their performance for each test. So we can see a clear decrease between the full context and the focused context. The more intelligent models like O3, they perform really well in both actually. So almost matching the focused context situation. But if we look at more older or smaller models, we see there's a significant decrease in performance. For 4.0, for example, it's almost like 30%. Overall, holding up well, but you can see the impact of the full context here very clearly. If we move on to Gemini, we see a fairly similar story. Smaller models drop off more. On the focused context, all of them work pretty well. One trend we also see is that thinking generally does help a lot for the full context one. So here we go from 72 to 90. Here we went from low reasoning. This only is a very small increase, but I think we'll see a similar story here. So for Claude is a bit of a different situation because Claude is very hesitant when it's unsure about the answer. So we see here with Claude Opus 4 thinking, it's doing fairly okay in the full context, but with the non-thinking variant, it drops down to 38, which is very low and even below some of the non-thinking models from earlier, like 3.5 and 3.7. What did I have here? Yeah. When so it abstains when in doubt. I was really wondering, a question to Kelly for afterwards, is this a consequence of anti-hallucination training, or what could be a source for this? Because I do know that Claude was really, they really want to have it work very well for coding and programming and those situations. And there, obviously, that's a very important thing. So I thought they focused a bit on that. The research also focused on why or how thinking and non-thinking impacts for the Claude model specifically, because there is that big performance gap. And we see that for temporal reasoning questions, we go from 27 on the full context up to 75. So a really large difference. A little bit less, but still similar for the multi-session one. We go from 36 to 61. And the knowledge update is a little bit less, 62 to 86, but still a very significant improvements, not distributed equally over the different categories of questions. And then the last one that we have here is Quen, which does surprisingly well, I thought. So the 235B, obviously quite a large model. It's performing about as you would expect, and then a non-reasoning model drops in both, and it's doing surprisingly bad actually in the non-thinking focused context version here, only 77. What surprised me here as well is how well the 32B is performing, and it's almost matching the 235B on most of these benchmarks, right? 68, 67, 93, 94, and the same for the non-reasoning version of this. And 32B is like, if you have a large MacBook, you can run that. And then the 8B is actually surprised me even more, because it's dropping almost no performance, like a couple percentage points here and there, and 8B is runnable on your phone almost. So I was very impressed by the performance of this. Like, I don't know how large Flashlight from Google is, for example, so I don't know if that's 8B or 32B, but here at least we know the exact sizes, and you can run them yourself locally. Yeah, I think that was the end of my Memeval section. I hope that was almost 2 minutes.
Yep.
Probably a bit longer.
You did great, actually. Whoops. I was trying to put the question link in. By the way, guys, I have to apologize to Matt. I got the order wrong. Matt was supposed to go next. I don't think it matters too much from the discussion because these are very unique and separate tests, but sorry about that, Matt. That's what happens when I'm working from a single monitor. Yeah. So Arham had a question to Kelly. Do you test with text-only input, or did you try mixing the type of input to text and tabular data?
We only do text-only input.
Okay. That was fast. Next question from Samantha. Why are there no error bars? How many times were each of these run?
Yeah, good question. We ran all these models on temperature 0, so they're all like deterministic outputs. So we just ran them one time. So yeah, if you set like temperature to like 0, they're like pretty much like reproducible.
Disagree respectfully. My experience has been even with temperature 0, you will see different results. So strongly recommend to anyone doing this kind of work, always run things in triplicate at least.
Yeah. Okay. Thank you for pointing that out. I did run it multiple times when I was just like testing it on my own too. And yeah, maybe adding error bars would be good to keep in mind. But I think for the most part, especially on this task too, because for long Memeval, it's only yeah, I think this was yeah. basically like when I saw this, I didn't see too much variation, so I just included that one number. And for this task specifically, when I was running it on like temperature 0, especially because like the task itself is like pretty simple too. It's just like question answering, and you just have like a binary success. Like, is it like correct or not? Like we saw very similar results.
Yeah, I think if it's all or nothing, it's a little bit easier, but we certainly saw even at temperature 0 for some kinds of tasks.
What kind of
And maybe,
tasks did you run? Just curious.
I mean, some of these were similar sorts of things where we were trying to do retrieval, but you know, doing like a query on a doc. So yeah, not that different from what you're doing. Sometimes we would just see it fail, and maybe it would be 10% of the time, maybe it would be 1% of the time, but sometimes it would just completely fail, even at temperature 0, even with all the same inputs and same model, everything the same. So I wouldn't necessarily trust the temperature 0 will always get you the same thing.
Correct me if I'm wrong, but the numbers here are just the average like accuracy or something, right? So I'm like in terms of error bars, like this is one aggregation. So what would the error bar indicate here?
I think
If
she's
there's
referring
any
to like
outliers.
multiple runs of this, right?
Yeah.
Yeah, okay. Yeah, but yeah, it's an average. So like, are we gonna average 3 averages or 5?
No, you always show the error bar, even with any kind of average, you always show it. That's
Well, so
the correct way to show an average.
But this is binary, right? So it's either true or false. So
No, but that's what I'm saying. It's if you have any outliers, your average is going to change, right? If you have any time that it fails, but
what's
you're
an
not going to know
outlier?
that unless you ran it enough times.
What's an outlier in a binary output?
That you got a 0 and normally you got a 1.
Yeah, okay, but I'm having like 300 zeros and ones.
Right. So then your average is not going to be 100% all the time. You're saying that the error bars should be the same for all of them? Is that your point?
Well, I think the number of experiments that are ran here are significant enough to not fluctuate a lot by running more of them. So we have for each of these bars is, what is it, like 300 data points? So if we would have 900, I don't think the average would change a lot, given that it might do like 1% point, but that's not a deviation that is
right. Well, my point is you're making assumptions about that, and unless we see the distributions, we're not going to know. Yeah, quantiles. I mean, there's other ways to show the distribution that could sometimes reveal there's more variation than you assume, and that's why you show what the distribution is, and not just an average.
Okay.
Yeah.
I mean, I think that would be good to make it more robust. So yes, I agree with you. I think that would be good for, I guess, having more like confidence on these results. I think for this specifically, like we do have the confidence just given that like making our claim that models have non-uniform performance across context length because we tested it across 18 different models. And each like bar is like an average of like 300 tasks. So yeah, that's like our main claim. But yes, I think adding error bars, that's like a good point to make it more robust.
Well, and also my other point there is that often when we've done these kinds of experiments and looked at the distributions, we find that it's very uneven. And so there are subsets of tasks where the differences are bigger, and sometimes that can be really informative. So often you learn more by doing it that way.
So I just want to compliment Samantha for the way she approaches that kind of challenge. First of all, I come from a family where you had to fight to get awarded at the table and we all argued. But besides that, this is what these sessions are for, to bring your knowledge to bear and to challenge assumptions of the folks. So thank you, Samantha, for doing that. I'm going to turn it over to Matt now. And Matt, will let you run, your period of time, and then we'll get into open questions.
Fantastic. Well, yeah, I think we've covered a lot of ground here, and I guess in the interest of time, I'll try to keep my bit relatively brief. I just wanted to check: are we going to? And I can see somebody's screen share still. Just want to if that's intentional. Perhaps what I'll do is take over the screen share and show the document in just a second, but I'll just before I share the document, I'll just say a few things in terms of background. So we've talked about the sort of needle question similarity, and one thing I wanted to disambiguate is needle question similarity versus needle haystack similarity, which is one of the things I'm going to talk about. What I wanted to just check as a point of order is, are we also going to cover distractors? Are we going to come back to Adam to cover distractors? Is that the plan?
I think I would love to. I think we're running out of time.
Probably.
So
Fine.
you would
Fine.
just
Let me at least close the loop on this needle haystack similarity point in that case, and something about structure, and then we can have open questions. So I will share my screen, because that is the hang on, I can share a window. Lovely. Okay, never mind. Let's see what
Benoit,
Zoom does.
can you give him screen share capability? I don't know that I can.
It's not so much, yeah, it's not so much that as I
You
can't
should
even
be able to see
describe
it,
the
Matt. Can you try one
the
more
use.
time?
No. The problem is literally the user interface on Zoom is so bad that I can't click the button because it's not on my screen. Instead, what I'll do is I'll suppose that people following along can see the paper. If you can't, I'll just make it accessible as I go through it, and we'll do it that way.
You know what? It's interesting. We have a developer here from Zoom, Ojas. I think he'll be able to fix it for you.
Zoom, Ojas, really. Yeah, this is on Linux. This is really, really bad. I'm sorry to say. Okay, so anyhow, the point of needle question similarity is to talk about the impact that is found when we have so just a little bit of just take a step back there. What we're doing is we hide the needle in some larger piece of context, and we're going to ask a question. We're going to try and find that needle in the context. And the question is, well, if the question we're asking is very, very similar to the needle that we've hidden, versus if the question is quite different, on that spectrum, how is the performance impacted? Well, we can ask a similar question about the relationship between the needle and its surrounding context. And that's what needle haystack similarity is looking at. So we want to know, and this was brought up earlier by one of the questions, right? It's we want to know if we hide a piece of information in a text that is very closely related to its surrounding text. I think the example on the right here, or the example on the left, this actually, I found this image not especially helpful, but the example on the left is like, okay, we have an essay, a piece of creative writing, and in the middle of it, we say the best writing advice I received from is to write every week. That's at least somewhat connected to the Paul Graham essay, versus thing on the right where it's very distantly related. It's really got nothing to do with the surrounding text. You can at least imagine a narrative where we're making a point about writing in a piece of creative writing, but you can't imagine a sensible narrative where we suddenly start talking about low latency rankers, re-rankers. So that's the idea here. That's what we're contrasting. And the interesting thing that is found, which has been highlighted by one of the questions earlier, is that almost counterintuitively, and it was certainly counterintuitive to me as well, that if you have that needle stand out, if it's completely unrelated to everything surrounding it, the performance is better. The large language model is somehow better able to recall that from the text. What they also found, and we've got the results here, we can kind of compare the numbers here. So they used two different corpora to do this. One was a bunch of archive papers. The other was essays from Paul Graham. Those are two really relatively different kinds of text, if you think about it as well. Paul Graham's essays are long form creative writing about startups and things related to that. Archive papers are going to be scientific papers like this. And what we have, so on the left, we're asking if the needle we've hidden is related to archive, how well does it retrieve if it's an archive-like needle, how well does it retrieve from an archive paper compared with a Paul Graham-like needle? I suppose it's worth remarking that the numbers here, the accuracies, aren't hugely different in this case. On the right-hand side, they're a little bit more different, but again, not substantially different. And I would echo the point that was made earlier about error bars and about asking ourselves, really repeating these experiments over and over again, and asking ourselves about, in the average case, how performance varies, which I feel is perhaps missing from this picture. In any case, that's the idea here. That's the idea, and I hope, certainly I hope that the needle haystack similarity versus needle question similarity is clear. The other thing that is worth looking at really briefly is structure and how structure impacts things. Because once again, this is something that I found surprising, somewhat counterintuitive, but maybe not surprising because our expectations about how a large language model reads a piece of text should not be, we shouldn't kind of overlay our assumptions about how we might read a piece of text. And maybe that's where our intuition gets messed up here. So they asked how the structure of a piece of text impacts the performance of retrieval when we're trying to retrieve these needles. And we can take the original piece of text. If you take an essay, then an essay should be a well-connected piece of narrative. Each paragraph should lead to the next paragraph. That's how we expect to read something, right? There's a logical structure to it. If you shuffle all of the sentences or all of the paragraphs in a piece of text, then it's not going to be very easy for us to comprehend. Well, it turns out that actually, and I just want to make sure I've got this right, that if you shuffle the sentences, actually performance at retrieval is better. And that's the thing that I thought that's kind of weird. And almost it's like maybe because there is no logical structure, the needle stands out. Maybe there's an intuition there. But again, that's kind of weird, right? It's kind of, if you were reading a piece of text, well, maybe it would be easier to find the needle if you're reading a piece of text that has no logical structure, because you would very quickly learn to not bother paying attention to the logical structure. In any case, I think that's all there is to remark on when it comes to structure. Just want to scan these last bits. And that, in that case, do we want to move on to whatever's next? I've kind of lost track, Arthur.
Sorry, I was on mute to save the noise in the background.
That's fine.
We have a couple of questions. We may have time. I really would like to get to distractors. And I want to make sure I get a chance to say one thing toward the end as a sort of a question statement, but let's go to the questions. John, if you're able to chat, John Savage, I assume, because I can see you, John. Hi. You want to ask your question?
Yeah, I was just curious about the impact of the thinking models, and just more, did you have a gut feel of why the thinking models perform better? Is it because they're kind of more reliably able to kind of like work with longer contexts, or is it more like an artifact of this exact task, this long mem task?
I wouldn't have enough confidence to say like what it is attributable to. I think generally for like more like complicated tasks, like having reasoning typically boosts performance, as we've seen like other benchmarks that these labs release too. So I think it's just like a result of the model, being able to like reason through, maybe think about like where this like needle is like located. And then I think especially for like long Memeval, like some of them require like multi-hop reasoning. Like first you have to think about like, like all the relevant parts of the context and then reason about like the answer. I think if you give the model the opportunity to like think about that, it typically performs better. So I think it could be generalizable. But yeah, we didn't run like specific experiments to like test like reasoning models, like the impact of them specifically. So I'm not totally sure, but yeah, I would think that it would generalize to more like complicated tasks.
Okay. Bauke, you're up, Bauker.
Yeah, my question relates to the shuffling chunks
Yeah.
increasing performance finding, which is surprising. And also, I feel like it should have an impact on like how we do RAG pipelines or long context Q&A. But I don't like, I'm not sure what that step looks like. Like, what are the things that
Right.
we now are going to change in frameworks, for example, or should we change anything? So I'm curious to hear if you had any takeaways from that in terms of practice.
Yes, I think for the haystack structure experiment, I wouldn't say there's a practical takeaway because I think like the main motivation for this was to see like, okay, like how does structure just like impact LLM behavior? And I think like ideally if you're working in like a Q&A or like retrieval scenario, like you would want to limit as much irrelevant context as possible. So you wouldn't want to like have those chunks in the first place. But I think like for this, it was really interesting because like we thought that, like having like a logically, like sound like haystack and then like a needle in the middle, that would kind of like break the logical flow and like therefore make it easier to stand out. But what we actually found was that, if you have like a needle in a shuffled haystack, we thought it would like blend in more, but that actually made the models perform better. So I think it was just like an interesting observation of like model behavior and more so like a direction for like interpretability rather than like practical applications for this. Like I think for like needle in a haystack, the main takeaway from that is to like limit the amount of like irrelevant context, limit the amount of like distractors, just try to focus your context on as much relevant information as possible. So I don't think there is something to like apply from this, but it was just like an interesting observation that we had. Hope that makes sense.
Yeah, a little, yeah, sorry. Yeah, but so maybe one follow-up. So because to me, it sounds like if I, say I have 100K tokens in my programming assistant context window, to me, it sounds like if I want to ask a question about something that's happened earlier, it would almost be better to chunk it, redistribute it into the context window and ask the same question, and it would work better. Or maybe I'm misunderstanding then the finding.
Potentially, but this wasn't really on like conversational. So I think like the type of context could like matter to whether you're working with like conversational like inputs or this is like just like archive and like polygram essays. So it might be different. But I mean, if you're working in like a long running like conversation and you want like your next query to tend to like a specific part of the context, like I think I'd rather do like a re-ranking step where you like maybe just do like another like LLM pass of like, okay, like what is like the most like relevant part of this context in relation to my question, and then do like another LLM pass, like asking it like the question. So I think like I would rather like filter the context for like relevant content rather than like shuffling it. I think that would lead to much better performance.
Yeah, okay, but that's also much more expensive. But okay, I understand
Yes.
where you're going.
Yeah,
Adam?
I was just going to back Kelly up on that. We had a similar observation that filtering works much better than shuffling.
Thank you.
I want to talk distractors because my comment has to do with that.
You want me to do a quick?
Yeah, do it quick because I want to talk about ambiguity. I really do.
Okay.
It's
So let me share that one. I thought distractors were really very, very interesting. If anybody wants to zoom back into them even afterwards. So the idea here, newer models are claimed to reliably handle any distractor. But is that true? And is that true as input length increases? So the idea is very simple. A distractor is a topically related concept. It's related to the needle, but it doesn't quite answer the question. And everything else that's not even related to the needle, we just call it irrelevant content. Right? So then the idea here is let's try to trip it. Let's give a bunch of different distractors. So what was the best writing advice I got from my college classmate? Well, the distractor could be the best writing tip I received from a professor, or the worst from a classmate, or the best from a classmate, or the something totally different. So the idea is to throw those in and then to see how performance degrades. And this is the case of no distractors. Here, when we throw one in and then we throw multiple in, and we see that almost unsurprisingly, the more distractors you have, the worse it gets, certainly as the input length increases. There's a couple of interesting aspects here, but another thing that's very fascinating is that one of these distractors is particularly pernicious. Why? What's happening there? One of them tends to be really throwing everything off, and then they go into a full error analysis modes to figure out which one it is, how to think about it a little bit. But that's the 30-second rundown.
Okay, and this was what was bothering me. Adam, that's why I wanted you to go first. So throughout this, Kelly, you keep
Yes.
talking about ambiguity, but you never
Mhm.
defined it. And I was like, okay, wait a minute. First of all, what really bothered me is, as I said, I am a wordy prompt engineer. I mean, I have literally at one point hit the limit of the context window. Okay, so that's how bad it can be. And basically you were telling me that, you know, I'm always going to do worse, that I need to be like the machine. I need to think like the machine. But I'm a product person. And I'm also, I've been doing AI, I was a robotics guy. I've always wanted the machine to come to me, not the other way around. And so what I asked ChatGPT to do, because I wanted to see this, is I basically wanted to recreate your experiment for the other direction. So what I asked ChatGPT to do is I said, we're going to do a long conversation. And in there, I'm going to ask two questions that are similar. And I want you to stop and tell me when you found the similar question. And so there were plenty of distractors. And I asked it at the same time, if we're going to do this, you have to tell me why it's ambiguous to you. So come up with an ambiguity metric so that I know my relative level of ambiguity. So we were doing this test and I realized, wait, let me look at length, to your point, context length, and I want to share my screen here versus, whoops. Thank you, hold on. I'm going to share two images. So the first thing was, what was the ambiguity? I had to go through, I've been doing with ChatGPT for 3 weeks, extensive work, like every day, hundreds of questions, hours of work. And I asked it to go through and take a sample of my questions and tell me, you know, what the average ambiguity was, and came up with a metric. I won't go to the detail. My average was 30 or so. And you can see the comment about distribution. Here is the distribution of my ambiguity scores on the various questions. Now, what really is interesting, and can you see this chart, the scatter plot? Can you see it?
Yes.
Okay. So I asked it to look at the number of tokens. This is the number of tokens, and this is the ambiguity score. And basically, the conclusion is there's very little relationship between the ambiguity score of my short versus long questions. And it's like, well, wait a minute. Now, do I interpret that as saying that slightly better, lower ambiguity, but higher ambiguity with longer questions? And the answer was, wait a minute. Maybe it's just that each individual has an ambiguity level in their questions. And that's the real driver here, is how much each individual actually is ambiguous in the way they speak. It's about natural language and how you talk to the machine. That's the question that I think I really would have loved to have us answer. And I actually could tell you the results of asking about the two questions, but I really wanted to point this out because I think the question was phrased, the whole point of the research. I just would have come at it as a practical product person, a person deals with customers from this perspective, rather than from asking how the LLM worked, ask how people work relative to the LLM. So that's my comment back to you. And I apologize if it sounds critical, but I wanted to at least people hear that viewpoint.
Right. So I think like you're curious about how we define ambiguity, I guess, because I think like if we just like talk about like ambiguity, it sounds, I mean, I think it's very subjective. So like in our research specifically, how we defined it is we use like cosine similarity between like needle and question pairs. We can't really do that with like just like one like individual question because to do like cosine similarity, you need like two like embeddings. But yeah, basically like we like ran this across like 5 different embedding models and we would get like the cosine similarity between like each like question and needle pair. So I guess that kind of gave us like a quantified metric for like how similar like needle question pairs are. And that's how we define ambiguity because I agree that just saying like, oh, this needle question pair is like ambiguous, that's not really like enough. So yeah, that's why we like quantified that through those metrics. But I think like for your experiment, like how did you get the histogram and like bars? I'm a little confused on that.
I will take that offline with you because we're 2 minutes over.
Okay.
I just wanted to point that approach, that turn it around approach issue to discuss it for further. But we're over time, and I always try to keep us on time. I want to thank everybody for coming. I want to thank our speakers who did a great job talking through. And Kelly, I want to thank you for taking time to come and present. And not only that, but to write the paper, because it's all very interesting work, and writing research takes huge amounts of time that probably you don't have given your day-to-day job. So thank you, everybody. And we'll see you all in 3 weeks, September 11th, right? Is our next session, Benoit?
Yep.
Right? Yep. All right, guys.
All right.
Very good. Take care.
Thank you, everybody. Thanks, Kelly.
Thank you.
Thanks, everyone.
Arthur.
Thanks, Kelly. Bye.
Thanks all.
Thank you.